Hey guys, this is Dr. Callahan for Probability and Statistics, Semester 1 for week 4, Thursday. Go ahead and pause the video to answer your warm-up log questions. Let's see if you guys can actually do this one. It says, experts say that you can find your name in this puzzle, then you're in the top 8% of the smartest people in the world. Not sure if it's true, but see if you can find your name. I hope you found your name, because if you found it, you're pretty smart. All right, let's take a look at question number 3. When we're graphing a line, there are two things that we need: slope and y-intercept. Your y-intercept is always going to be the last number by itself. Slope is always in front of the x. So I'm graphing this. I'm going to start out at 2. I'm going to go up 5 over 1. Notice how you're actually losing some space here, in which case you can also go down 5 over 1 as well. And then just connect the dots. And that should be your line. Same thing here. Start with a -4. And then your slope is a 4 over 3. So I'm going to go up 4 over 3, up 4 over 3, and then connect your dots. So last time we went over this, we talked about the different objectives of permutation and also the counting principle. So let's take a look at the first one here. So for objective number 1, let's go over the answers. This is: a restaurant offers 8 entrees, 7 desserts. How many different ways can a person order a 2-course meal? And before I go over this, this is actually section 11.1. This also is a new packet. So your old packet, you should have put in folders in my classroom when I saw you in person, and you should have put them away into the green bin. So this is your second new white packet. And so if you have not received that one yet for section 11 or unit 11, make sure you come see me and get that one and turn your other one in. So a restaurant offers 8 different entrees, 7 different desserts. So how many different ways can you go ahead and order this? You could just do 8 times 7, which is going to be 56 different combinations. Also, this restaurant offers 12 entrees, 6 different desserts. You're going to do exactly the same thing, which is going to give you 72 different combinations. Lastly, they have 9 entrees, 4 appetizers, 5 dessert. You have to multiply this together. So 4 times 45 is going to give you 180. Okay. Objective number 2, let's go ahead and take a look at this one here. For this one, it's asking you how many different ways can a girl choose a 2-piece outfit: 5 blouses, 8 skirts, multiply them together. You should have 40. Similarly, 4 blouses, 6 skirts, multiply them together. 24 different variations. 8 blouse times 5 skirts times 6 pair of shoes. That's going to give you a 40 times a 6. 4 times 6 is 24. Don't forget the 0. So 240 different combinations. You also have a little bit of textbook on the Google Doc. Remember, you always have a picture on the Google Doc of your textbook. You were supposed to do number 2 to 24 evens. So go ahead and pause the video and check your answers. Okay, so today we're going to go ahead and talk about 11.2, which is a combination of, or just combination and permutation. We're going to talk about the differences of the two. Basically, order matters. We're going to do objective number 3, and then afterwards I have a YouTube, which is going to be part of your guided notes. It's 11 minutes, quizzes, and then if you need some additional assistance, I have the following as well. Your homework tonight is 11.2. 2 to 24, 34, 36, 42 to 46 evens. So make sure you are doing that. All right, let's go ahead and turn over to this page. Let's take a look. Permutation is going to be similar to example 10, but this right here is a number of permutations, and let's go over what the letters represent. N represents all letters in a word or all letters involved in something. P is going to equal to the first repeated letter. And Q is going to be the second repeated letter. R stands the third repeated letter, and so on and so forth. So P, Q, R, we could do S, which is the fourth, and then ST, which could be the fifth repeated letter in a word. So example 10 is how many different ways can we go ahead and write the word Mississippi, and how many different ways can it be rearranged? Well, you could try to go ahead and rearrange them in different orders of each of the words or the letters, but that's going to take you literally forever, and I don't really want to do that. So let's go ahead and use this fancy little thing here so we can go ahead and figure out how we can do this. Okay, so let's go ahead and take a look at this. N is going to be all the different letters in the word Mississippi. How many are there? You can count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters in the word Mississippi. So then once I have that, you know I need to figure out what P is. P is going to be the first repeated letter. I is definitely repeated. How many different times is I repeated? 1, 2, 3, 4. So 4 times. Next, I want to do the Q, and the letter that's second repeated is S. How many are there? 1, 2, 3, 4. So that's going to be 4 as well. And lastly, you're going to do R, which is going to be the letter Q. That's going to be repeated. And that's going to be, I'm sorry, not Q, P. And that's going to be 1, 2. So now that I have P, Q, R, all the repeated letters, I can now go ahead and take this and plug it into this formula. So I'm going to have 11 factorial over 4 factorial times 4 factorial times 2 factorial. So what that means is that a factorial is when you go ahead and do 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. You're basically going from the biggest number, which is 11, in order all the way down to 1, so in descending order. So then here you have 4 factorial. That's going to be 4 times 3 times 2 times 1. And here you have 4 times 3 times 2 times 1. And the last one times 2 times 1. And if you take a look at this right here, 4, 3, 2, 1, 4, 3, 2, 1, I can go ahead and take that and just cross it out because it cancels. Numerator and denominator are exactly the same numbers. It just cancels out. Then I'm going to take a look at the rest of the part. I know that I have 4 times 2 is going to give me an 8. And that 8 is going to cancel with this 8. Boom, done. Then I'm going to go ahead and link 3 and 2 is going to give me a 6. My 6 and the numerator 6 cancel. Boom, done. So now essentially all I have here is just 1s in the denominator. And on top, I have 11, 10, 9 times 7 times 5. So if I go ahead and multiply those numbers divided by 1, how many different ways do I have to rearrange the word Mississippi? 34,650 ways. So it's a good thing you guys didn't actually write out the different combinations to Mississippi, because that would take you forever. All right, let's talk about the differences of combination and permutation, and there are several. Okay, so the first one is combination. In this one, order does not matter. Keyword here being order. So if something does not matter, like the order doesn't matter. Like for example, if you're on a team, you're one of many different team members. You do not matter. There's no I in team, so you're just one of the players. Okay, like in sports. So everybody's on a team. So order doesn't matter. Permutation is when order actually does matter, okay? Like for example, if you're on, I don't know, if you're like running for the, or actually I should say, if you're at the county fair for, I don't know, hot dog eating or butter carving, whatever tickles your fancy. There's obviously a first place, a second place, and a third place. So order in this situation really does matter. Or better yet, in November of 2020, we're going to have a presidential election. So order does matter because there's a difference between being the president, the vice president. I actually don't know what else. I guess you could be the press secretary. I guess you could be the person in charge of housing, etc. All of those do matter. So in which case, if order does matter, you will be using permutation. And also what you should notice is that the formula is vastly different. The first one on top is for combination. One on the bottom is for permutation. I shouldn't say vastly different. I guess the only thing that's different is with combination, you have R factorial on the very bottom in the denominator. All right, let's go ahead and take a look at objective number 3 using factorials and combination, permutations, etc. So objective 3, you need to rearrange 5 of your favorite book on the shelf. For how many different ways can you arrange a book, assuming the order of the book matters to you, and you want to go from the longest to shortest, okay? So in this case, it's just going to be a 5 factorial. So you're going to go in descending order, 5 times 4 times 3 times 2 times 1. You don't even need to write the 1 because anything times 1 is going to be that number. So what does all these numbers multiply together equal to? 120 different ways. All right, so similarly, if you're going to do the next one, 9 different methods or different way of rearranging. So 9 factorials. 9 times 8 times 7, 6, 5, 4, 3, 2, 1. If you're going to multiply everything here together, what would that be? I hope you're ready. 362,880 different ways. Well, it's a good thing you didn't just take 9 of your favorite movies and rearrange it, because that would take you all of the last 3 days over your 3-day weekend. All right, I am actually done with this one. What I want you to do right now is watch this video right here. It's actually going to go over these 1, 2, 3, 4, 5 different examples of combination and permutation. So you could either type this tiny URL down, or what you can do is you can go to my Google Doc, scroll down to week 4, Thursday, and you have this link on the Google Doc as well. So make sure you watch that video and answer these 5 questions. This is your exit ticket for today. What was the most important thing you learned and why? And what was the second most important thing you learned and why? You're welcome to go ahead and get started with the quizzes as well. Other than that, I will see you guys next time. Have a good evening.